Okay, this is our fourth type of reaction. It's called double, which means two. Replacement, a word we've seen before. And so what this means is we're going to place again. Re means again. We're going to replace again, but we're going to do that with two compounds. So this is a situation where I have compound AB and CD, and depending on what the charges are, I'm going to choose to switch out positives with positives and negatives with negatives. Now, that's because if I have a positive and a positive, these will not come together. They're going to repel each other. So we need opposite charges when we make a compound. That's a good check to make sure you're doing it right. So let's assume that A is positive and C is positive and B is negative and D is negative. Because when you write compounds, the first element's always going to be the metal, and it will be positive. So in this scenario, I'm going to switch the nonmetals. So I'm going to replace B with D and D with B to make two new compounds. Right? So now I have AD and CB, and that's the pattern that we observe in this reaction. Okay? A real example of that is I might have magnesium hydroxide, and I might have hydrochloric acid right here, HCl. Okay? So I'm going to use my periodic table. I find magnesium, positive 2. Okay? I find hydrogen, positive 1, and chlorine is a negative 1. And then hydroxide is a polyatomic ion. So I'm going to have to go to my sheet here to use it. I need to find hydroxide. It's right here. It has a negative 1 charge. So since that's negative 1, magnesium is positive 2, positive 1, negative 1, I'm going to have two of these hydroxides, and you'll see that before you have to balance it. Now, this 2 does not necessarily come over here with hydroxide. It's only there because the charges are not equal. So these numbers down here are determined by the charge, and they happen at the end of predicting a product. Okay. So double replacement, we're going to switch like charges. So I'm going to take the metal, magnesium, and switch it with the hydrogen. So I'm going to get HOH, which actually is a common compound we use all the time. HOH is actually two H's and an O, or also known as H2O, or water. So that happens. I got a negative 2 and a positive 1, so I have 2 hydrogen. But I could also look at it like I have a positive 1 and a negative 1, and they come together. So magnesium is a +2 charge, and chlorine is a negative 1 charge from before. And now when I look at this, I can see that these are not balanced. So I'm going to drop the 2 to chlorine, and since that's a 1, I just leave magnesium alone. And this is correct answer right here. It's really done really well. Now, you might have this with like a different compound, like sulfate, a different polyatomic ion. And you might even have hydrogen and a polyatomic ion, like cyanide. So this is just showing that we're going to use this quite a bit, and you might use it for different reasons. Sulfate, remember, just look at it, SO4 is a part of the package. And so if you can put all polyatomic ions in parentheses, you know that these elements are always going to stay with each other and treat them just like one new element. So sulfate over here, negative 2 charge, magnesium, positive 2, hydrogen, positive 1, and then cyanide right here is a negative 1 charge, okay? Now, we can do a double replacement. We're going to replace the negatives this time. So cyanide and sulfate will just switch places. Simply put, that's what we're going to do. So we have magnesium cyanide, and we have hydrogen sulfate, or what we call sulfuric acid. And then we add those charges so we can balance them out to finish it out. So when we do that, we see an unbalanced charge. So if I have a +2, I just need an extra cyanide. And this is how you do an extra polyatomic ion. You don't put it by the end. It needs to be outside of the parentheses. Right? Then over here, I have a -2 charge, and so I can put a 2 by the hydrogen to make that work. And that's the correct answer.